Anyone have any questions before we start? Sometimes when I'm in front of an audience like this, I try to practice my psychic powers. I have some beginner level psychic powers, just basic beginner level, and I try to use them to read your minds or anticipate questions or something like that. So I'm going to practice the collective psychic reading right now. I'm picking up this signal. Somebody in the audience has something on their mind, but they're just afraid to say it. It's not a question, so they can't say, oh, I have a question. They just want to say, Happy Halloween. Am I right? Was somebody thinking Happy Halloween? I'm sure there was somebody thinking that. So, just to bring to your attention, there's an early module feedback. So you don't have to wait until the end of the module to provide feedback. You can provide feedback now and steer the way the rest of the module goes, if you want to influence the way the rest of the module goes. Also, it's okay to leave some positive statements, like this is an amazing module. It's helping me prepare for job interviews. I never expected that. And I never expected to learn so much about software engineering. Things like that. It's okay to leave positive feedback. So we'll leave that up. It won't be up there forever. So, probably at the end of this week it will be removed. So you have this week to leave some module feedback. Okay, and if anybody does have comments or questions, feel free to interrupt me at any time. Today we're going to look at collaborations, class relationships, hierarchies, and subsystems. It's kind of a lot of information. It's a lot of information because it's those two lectures back to back, essentially. Just as a 30-second recall, we're going through the design process. The first two stages we went through were identifying objects and identifying responsibilities. So this is sort of stage 3, 4, and 5, collaborations, hierarchies, and subsystems. So a collaboration is just a communication, the flow of communication amongst all those thousands of objects. Usually your application has thousands of objects. How to understand that communication and how to document it, right? Collaborations are a way to formalize this pattern of communication. A single collaboration is one way from the client to the server. That does not necessarily mean that information flows in only one direction. Remember, there's two directions, right? There are input parameters to a method call, but there's also a return parameter. So the input parameters represent information from the client to the server, and then the return parameter represents information from the server to the client. So each collaboration addresses one responsibility in a server, and each collaboration helps to fulfill one responsibility of a client, but one client responsibility may need many collaborations. This is a way to draw collaborations or patterns of communication between objects. Here's a class called A, and it has a responsibility A1. This is a communication to class A. This is a communication to another class B and another class C, right? And the collaboration is given this label B1 and C1. So the collaborations are represented with these arrows from left to right in this case. And then responsibilities are labeled with A1, B1, and C1. So really simple, right? In the design process, you might generate these kinds of collaboration diagrams manually by hand. You might take out some pencil and paper, or you might use PowerPoint or whatever, some drawing editor. Anybody know how these kinds of collaboration diagrams could be generated automatically? Imagine you're given a piece of software like Snake, this like for your course, and you wanted to understand the patterns or the flow of collaborations, and you wanted a collaboration graph like this, and you wanted it to be generated automatically. Anybody know how to do that? Is that possible? Anybody know if it's possible? Okay, I'm glad I'm asking this question. If nobody knows the answer, then it's a good thing to know, isn't it? It would be a good thing to know. Sean?
It's possible. If the software doesn't exist, someone could make it.
Yes, that's that's a creative answer, yes.
I'm assuming intelligent.
Yes, there are a number of tools that let you generate these collaboration graphs automatically. I don't know if the free version of IntelliJ does it. It might be the paid version. There is a free tool called Doxygen that will let you generate the collaboration graphs automatically. It's extremely impressive. It's like, every time I see it, I'm just amazed. In fact, at one of the companies I worked for, they didn't know about source code documentation. They just didn't know about it. They didn't know about JavaDoc. They didn't know about Doxygen. Some of you will experience this, by the way, when you go into industry. You're going to arrive at a company, start maintaining software, and discover that they don't know about documentation tools. If you make that discovery, which is a very, very high likelihood you're on a failing project. And I remember introducing Doxygen to one of the companies I worked for and generating the collaboration graph for the very first time on their software automatically and being shocked at how bad it was. Anyways, maybe you'll have a similar experience. So patterns of class collaborations and relationships represent the flow of control and information in your application and define a communication pattern. And they can also help define or identify subsystems, which we're going to talk about in the next lecture. So how do we find these collaborations? It's not actually difficult in reality. I mean, you'll just... they'll come out when you're writing methods for your class. I mean, responsibilities imply collaborations. So as soon as you write down your responsibilities, you'll start to see the collaborations. So look for dependencies among responsibilities. For each responsibility of a class, is the class capable of fulfilling the responsibility itself? If not, what other collaborations does it need, or what other objects does it need to fulfill its responsibility? Shared responsibilities can define collaborations. So for each class, what does this class do or know, and what other classes need these actions of information? Right? If no interactions are necessary, it might be possible to eliminate the class. So this idea of class relationships comes up over and over again. Actually, I guess that's going to come up over and over again through your whole degree program. That's because it's really important. So we look for common class relationships, right? The component hierarchy was one of them. That's the is part of, like a tire is part of a car. In the snake game, you might have, a snake could have components like the head of the snake and then the tail, right? Those are two components. So head is part of snake, tail is part of snake. That's just an example from the coursework. So this defines a whole part relationship between two classes. One class is a composite object, the other is the component, right? And we're also going to talk about design patterns, and this is a common design pattern or relationship found in the design patterns. Has knowledge of is another kind of relationship between classes, right? Composite objects usually have responsibilities for maintaining information about its components. If a class has a knowledge of B, usually this implies a collaboration. Just knowing the existence of another class usually means there's a collaboration. So for example, in the just a boring example might be the date class. The date class is going to have access to a time class. So time doesn't have to be part of the date. It could just be that the date has knowledge of the time object, right? Depends upon is another kind of class relationship similar to the has knowledge of, but maybe a third class that maintains dependency or visibility. Again, this is found in some design patterns that we're going to talk about. One's called the observer design pattern. So that's something we're going to discuss. Composite versus container objects. These are very subtle differences. Basically, composite objects are also called object hierarchies. And every component in the hierarchy has a different role to play as opposed to being identical, right? So if you have a car object, you have thousands of different component objects, right? You have wheels, like wheels are a part of the car. A steering wheel is a part of the car. The passenger seat is a part of the car, and so on, right? That's a composite object. The composite is responsible for its parts. It knows about the parts. So the car object knows about the passenger seat and the driver's seat. But the driver's seat doesn't really have to know about the car. Right? You can pick up the driver's seat, throw it out, and replace it with a new one. Right? The car knows about the driver's seat. It's not a perfect analogy, but hopefully you get the idea. And then we have container objects where every element in the composite is basically the same, right? And they're all treated the exact same. So elements in the container are functionally identical as far as the container is concerned. They all serve the same role. These are things like sets, arrays, collections, and so on, vectors. Containers may need to collaborate with their elements, but usually container responsibility is just passed along, right? Okay, and if we want to document collaborations, remember in the last, well, I guess it's not easy to remember, but if you can remember in the last lecture, we introduced this documentation, these cards, where we recorded class names, superclass names, subclass names, and responsibilities. So now we're extending that to include collaborations. So we have a class called creation tool, we have a superclass called tool, we have subclasses called line creation tool, rectangle creation tool. These are the responsibilities: accepting appropriate input, determining location, creating a new instance. And these are the collaborations. So these are other classes. Right? Accepting appropriate input might be handled by a class called user input. Determining location might be determined again by handling user inputs. And then creating a new instance might be handled by another class called DrawingElements. Right? Determining user input, that if you're trying to draw something, remember, this is the example from the drawing editor, you need to know the location of something. Anybody know what that thing is you need to know the location of, besides Sean? If you're trying to draw something, what would you need to know the location of? Anybody awake? I guess it's Monday and everybody's kind of sleepy, thinking about trick and treating. Name?
It would be the mouse.
What did you say your name was?
Callum.
Callum. The mouse. Yes, exactly. I would say the cursor, but you could say the mouse. Yeah. Yes, exactly. Thank you, Callum. So somebody's awake. Any questions about collaborations? It's kind of a short topic. Collaborations will come out very naturally, I think. They're just a natural byproduct of defining responsibilities and then developing your methods. They just come out. A good exercise for the coursework is to generate a collaboration diagram for the classes that you have there. Yes, thank you, Sean. What's your question?
With a composite object, you said it was an object hierarchy. Is that a strict hierarchy? Like where only
I would call that a flat hierarchy.
flat?
Yeah, like you have one parent and several children at the same level. Yeah, yeah. Any other questions? Those kinds of, that's like, you could find that at a job interview. Somebody could ask, can you tell me the difference between a class hierarchy and an object hierarchy? That would be a really difficult question. It's a valid test question, interview question. I would be surprised if somebody asked that, but it's definitely something somebody could ask. It would have to come from somebody that really understands object-oriented design, which there aren't that many people that understand it. You might think I'm crazy, like, Bob, how is that possible? Like, we have all this software being developed in the world, and I use it every day. I guess it's probably related to something, I think it's called survivorship bias. Has anybody heard of survivorship bias? Sort of the name implies the meaning. You only see the software that survived and succeeded. You don't see the software that failed, and most of the software fails actually. So it's very surprising, at least for me, to learn, like, oh my gosh, really most software actually fails? So if you actually do end up as a software developer, the chance of you working on a failing project during your career is extremely high. Extremely high. Okay, let's talk about software hierarchies, which I think you're all a little bit familiar with, but maybe you didn't talk about it in this much depth, maybe. So this is, by the way, why are we talking about this? It's because creating these hierarchies is the big advantage, one of the big advantages to object-oriented design. This is like bringing out some advantage that's very special and very useful. And does anybody know what the advantage of class hierarchies are? What advantage, or what's one of the advantages they provide? That's a great, I don't think you'll get that in a job interview, but that would be a great job interview question. What advantages do class hierarchies provide? Any advantages? If you know the answer to that question, that's really good. One of the benefits is they maximize code reuse. So in your parent class, you have a method, or maybe you only have some method signatures, but you can reuse that behavior and that implementation over and over again in the children. So it's really maximizing, or trying to maximize code reuse. The more reusable the code is, the better, right? Because you're not reinventing the wheel over and over again. What were you going to say, Sean?
Isn't the problem as well is that the changes in higher classes could propagate down and lead to unexpected errors?
I suppose it's possible, but I would say it's unlikely. Because the parent classes shouldn't really know about the child classes. The child classes know about the parents, but the parents don't necessarily know about the children. So it could be possible, but it should, if you're careful, it should be very unlikely. Yeah, so this is maximizing code reuse. That's the idea behind hierarchies. And you want a language that supports hierarchies, right? You all took C, I think, in your first year. C is not object-oriented, really. It's not easy to create a class hierarchy in C, which is why C++ was invented, right? So this is the next stage of the design process after objects, responsibilities, and collaborations. And then they represent sort of one of the key properties of object-oriented design, right? And we can use different views of these hierarchies, like hierarchy graphs, Venn diagrams, and they can be confused with collaboration graphs too, by the way. So that's a hierarchy graph. This notation is from the book that we're looking at, the Worfsbrock, Designing Object-Oriented Software. So in this, how do we read this? A selection tool is a kind of tool. A creation tool is a kind of tool, right? Ellipse is a kind of creation tool. Line is a kind of creation tool. Rectangle and text. Remember, this is that DrawingEditor example that all the slides, unless otherwise noted, the slides are referring to this DrawingEditor example. And then these little black squares represent abstract classes, so classes with no explicit implementation provided, just the behavior, so to speak. So the method names, method parameters, and return values. Multiple inheritance, I guess you've all heard of multiple inheritance. I mean, we are examples of multiple inheritance, right? We have two parents usually, right? Maybe that's changing nowadays, but at least for a lot of people, we are examples of multiple inheritance. And here's an example of multiple inheritance, right? An array is a kind of ordered collection. An array is a kind of indexable collection. And then matrix is a kind of array. String is a kind of array. And string is a kind of magnitude. And date is a kind of magnitude. So this is pretty complicated. And it's actually really complicated if you look at it, if you look at the string class. So a string is a kind of magnitude, a string is a kind of ordered collection, and a string is a kind of indexable collection. So it's really complicated. In fact, it's so complicated, it's very discouraged. Name?
Zachary, just a quick question. What do you mean by magnitude?
So magnitude means length, just length. So string has a length, right? Date has a length, and so on, yeah. This is complicated, isn't it? Anybody know, like, this is complicated to my mind, or to the collective mind, but there are some problems with multiple inheritance. This is a very advanced question. What's a technical problem with multiple inheritance? Like, what can technically go wrong if you implement multiple inheritance this way? Name?
Peter.
Peter.
If you have two parent classes with the same method name, and then you call that method name on the chart, it doesn't know which one to...
How did you know that, Peter? That's a really good job interview question. Like, that's a tough one too, I would say. So Peter said, what if you have two classes with the same method name? They're both parents, for example. Which one gets called? And there's another problem too. Sean? Like, does one get called or both of them get called? And if both of them get called, which order are they called in? Really problematic.
This would just be like a compile time error, because it's obviously an accident.
Yes, hopefully it's a compile time error, yes. But that's the kind of thing we really hope to avoid, is compile time errors. We don't really want what we're doing to depend on which compiler we're using. We're trying to write software.
You should put it in the standard. That standardized it should come up with an error.
Theoretically, that could be true, yes. If you look up the documentation on compiler standardization, you'll get like 20 million pages and it might not all be the same. Yeah, so we're trying to avoid that. But even if it worked, like, I would get confused here too. I wouldn't want to rely on my brain to sort this out. Another problem is with the parent constructors. So when you instantiate a child, you instantiate the parents. And then the question is, okay, how does that work? Which one gets instantiated first? Yeah, that's a problem. I don't know the answer. I think the answer is it depends on which compiler you use. I think that's the answer. But I don't want to worry about this. And you guys don't actually have to worry about this either. I don't think there's multiple inheritance in the Snake program. Anybody remember how Java handles multiple inheritance?
Does it have to?
Yes, it doesn't. It almost has it. Almost doesn't have the official sort of multiple inheritance feature. But you can, let's say, that's right, through multiple interfaces. So you can inherit multiple interfaces, which you could also call like abstract classes. In this case, there's no implementation, so you don't have to worry about something being executed before another thing or what gets executed and so on. So Java said, oh, multiple inheritance, bad idea, we're not going to support this in our language. I'm sure you can find some people that will stand up and say, Bob, that's so wrong, I know multiple inheritance is great, like blah, blah, blah. So you can find other people's opinions. This one just happens to be a better opinion. Okay, has everybody seen Venn diagrams before? Maybe some of you have, maybe some of you have not. Who has never seen a Venn diagram? I actually do not remember the first time I saw a Venn diagram. I cannot remember. I can't remember if I was in high school or college or university. I'm not even sure. But here's a graphic representation of responsibilities, right? Venn diagrams can represent responsibility of a class as a set, so shared. Responsibilities show up in a Venn diagram. So we have three classes here: selection tool, creation tool, and tool. These two ellipses overlap, right, between selection tool and creation tool. This overlapping area is a special area. It means this is what the two ellipses have in common. Right, so the tool, the parent class, it represents what the two child classes have in common. Right? So that's the overlap. If they overlap, they have something in common. Here's a cool one. This is that same example from the previous slide, the multiple inheritance example. So that's what the Venn diagram for the multiple inheritance example looks like. It doesn't look that bad, but then when you start to try to process it in your mind, it starts to become very confusing. Because you see like ordered collection overlaps with array, matrix, and string. Right, and string and matrix overlap here, and that overlap is called array. It starts to get confusing. So guidelines on building good class hierarchies. Put a star on this slide if you can take notes or something like that. Hierarchy and Venn diagrams can help in this analysis. So the hierarchies always follow this is kind of or is type of. And a guideline is if you can say it in a sentence and the sentence makes sense, it should be fine. Right? Like a rectangle is a type of figure. Right, or a rectangle is a type of polygon. If you can say it in a sentence, it should be fine. And the sentence makes sense. But you can also get people to say very strange sentences when it's not working, right? Like, a rectangle is a type of, canvas. For example, I've seen examples of students saying very strange sentences in the middle of the class. They say, is a kind of. Like I say, are you sure about that hierarchy? And then they'll say the sentence out, and the sentence doesn't make any sense. So if you're not sure, put it in a sentence and see if the sentence makes sense. So in these kinds of hierarchies, common responsibilities are factored up or raised as high up the hierarchy as they can for code reuse. So sharing the responsibilities amongst as many classes as possible. Right? This is the really good part of object-oriented design. Don't allow abstract classes to inherit from concrete ones. So you'll never have this case where abstract is inheriting from concrete. It should be the other way around. Right? And eliminate non-functional classes. So here are some examples. Class A is derived from B only if it supports all its responsibilities. A is a kind of B. So this is a multiple inheritance kind of class hierarchy again. So if the relationship here is, if this is correct, if this Venn diagram is correct, where E is an object and F is an object and they have some shared responsibilities, then this class hierarchy is incorrect. Does everybody see that? So this is they only share some behavior, not all of the behavior. So for example, F does not share all of the responsibilities of E, just a piece of them, like a small piece. So in order to rearrange this hierarchy, we have to represent this shared behavior in a new object called D. In this case, it's an abstract parent. And then that shared behavior is inherited by E and F.
What do you mean by shared responsibility? Can you give an example?
So shared responsibilities are basically methods. If you hear the word responsibility, this is how I think, let's say. I think of verb, and then when I think of verb, I think of method. So shared methods. So an example could be like draw. So a square knows how to draw itself, but it could have a parent called figure. So a figure knows how to draw itself, a square knows how to draw itself, a triangle knows how to draw itself. So they're both pointing to the parent figure, and they're both, the draw is the responsibility, like to draw yourself, and they both inherit that. Could be a good example. The other type of responsibility is the information about that, like the size. Right, you might have a size. So that could be another method, get size, right? So square has a method called get size, rectangle does, triangle does, and there could be an abstract method, a figure called get size. Yeah. By the way, there's a method common to all objects in Java. That's a shared responsibility for all objects in Java. There's a lot of objects in Java, right? Does anybody remember what it is? Sean?
Get ID.
Is get ID a shared one? I don't remember, actually. Probably.
Shared what? Method?
A shared responsibility or method.
Having an ID something?
I think for object serialization you need the ID, but I don't know if it's common to every single Java object. There's an object called just like object or something. Anybody remember one of the responsibilities in there that everybody shares? Almost. Yes.
Oh, toString.
toString, exactly. Yes, toString. So that's an example of a shared responsibility for every object in Java. And that will be abstract, right? Or it can be abstract, because every method really, every class really has its own version of toString. I don't know if it's abstract or not, actually. I mean, it could provide a default implementation that's just object. Like if you don't tell me what my string method is, then my print method is, then I'll just print out object. Okay, so move common responsibilities up the hierarchy. Factor common responsibilities as high as possible. If a set of classes support a common responsibility, they inherit it from a parent. Those are the examples we've just been talking about. Design as many abstract classes as possible. This is likely to result in maximal design simplification, design sharing, and code sharing. And it's likely to make the system more or easily to extend in the future. Decision criteria for creating abstract classes can involve speculation on possible future extensions and modifications, right? The example I gave just a minute ago was with the figure. That's not too hard to imagine. You're going to have lots of different kinds of figures. Squares, rectangles, triangles, polygons, octagons. Who knows? It's hard. It can't really predict every kind of figure that it's going to have, but you can speculate on future versions. One responsibility is enough to justify an abstract class. So just draw, for example. That responsibility for a figure to draw itself is justification for that having that one abstract class. And same with the Java object. So maybe Java object only has one responsibility, it's toString. I can't remember what else is in there. But if that's enough, that's enough. By the way, every parent really should have 2 children, right? Having one parent and one child is not a good idea unless you're confident that you'll be adding more children in the future, right? Sometimes it's obvious. So here are some examples. This is that drawing editor that I keep referring to. And this is how we factor common responsibilities up the hierarchy. So we have this abstract class called drawing elements. It has text, lines, ellipses, rectangles, and groups. Everybody's used a drawing editor, hopefully. Line, ellipse, and rectangle all have an attribute representing line style, right? So line style could be like solid edge, dashed edge, dotted edge, or like different colors of the edges, right? That's a shared responsibility, but is not shared by text and group, so it cannot be assigned to drawing elements. So create a new abstract class to support the line style responsibility. And that's what that looks like. So we have drawing elements, text, linear, group, and then those linear elements have line style. Now, ellipse and rectangle also have a fill style that is not shared by lines. So ellipses and rectangles cover an area that an edge or a line doesn't cover an area. So there's some implied shared responsibility with ellipse and rectangle. So we can revise the hierarchy to look like this, right? Text, linear, group, line element, filled element, ellipse, and rectangle element. That's an example of factoring responsibilities as high up the hierarchy as possible. Abstract classes should not inherit from concrete ones. So that means abstract class behavior should be implementation independent. So this is an example of not a good design. Remember, these squares indicate abstract classes. Concrete class behavior may be implementation dependent, right? And this characterization is violated if an abstract class inherits from a concrete one. For some reason, I can't explain it, but I guess I've been looking at this material for a long time now. And so for me, this is automatic. I don't have to think about this at all. That abstract classes are always at the top, above the concrete classes. So this situation can be fixed, right? If you have a design with a child class that's abstract, you can fix it, so to speak, by introducing a new class that, again, represents the shared behavior of Class C and Class A, so that you don't end up in this situation. And then classes that add no new functionality are often eliminated, right? Responsibilities represent only public, right, services, methods, public methods. That's a little reminder. Responsibilities are inherited by children but assigned to parent. If a child implements the parent responsibility in a different way, then it adds functionality, right? Like the display methods that we were talking about as examples. Okay, here's a little quiz, a pop quiz. Here are 2 class hierarchies. They violate a principle that I mentioned, really, that a parent should have 2 children, but this is just an academic example. Which is the better hierarchy? That's the quiz. So you'll be assessed on this right now. Not really. But have a look for 30 seconds. Actually, ask your neighbor, if you have a neighbor, turn to your neighbor and figure out which one you think is the better class hierarchy and why. So we'll resume in 60 seconds. This would be a cool job interview question. Anybody want to attempt to answer, name?
Dan,
Dan.
the one on the right is better.
The one on the right is better. Any explanation?
Because the classes get less powerful as they go down, so lower level classes are higher up, so they can do more, whereas lower level ones are just sort of derivations of the higher level. Well, yeah.
So the parent classes can do more, is that what you said? Is that the justification?
Yes.
Can anybody help him? Does anybody agree or disagree? What was it again, Zach?
I agree with that.
Okay.
Because one of the principles you said is like you want to put sort of responsibilities as high up as you can, and the rectangle is sort of the most general case. So, and then it gets more constrained as you go down. So you, depending on whether you want to do something on just a unit square or a square or a rectangle, it sort of cascades up or down quite nicely. So.
Anybody think that the one on the left is better? Name?
Zachary, but I might be completely wrong.
Tell us why you think the one on the left is better.
I thought, after hearing the arguments, I actually understand the arguments, but what I discussed originally was, I thought maybe unit square because everything bases off of it, if that makes sense. So everything builds off of it.
Okay.
So that should be in at the most power, if that makes sense.
The most power. Anybody want to support his answer? It's Zach, you said? No. Yeah. Name?
James. Units. So the one on the right takes away functionality from the classic. So the one on the left, when you go on to child, that adds functionality.
The one on the left adds functionality, and the one on the right does not add functionality. Are there any guidelines for identifying good hierarchies? Did we discuss any guidelines? I'm so tempted to let Sean answer, but does anybody else want? Did we talk about any guidelines? Yes or no?
Active common responsibilities as high as possible.
That's right. Any other guidelines? There's one super important guideline. Okay, so let's get a volunteer. Remember the is kind of relationship or is type of? Does everybody remember that guideline? Really important one. So who thinks the one on the left is the correct one or the better one? Zach?
I just read it out and it's a rectangle is a type of square, which is a type of unit square. So that would read correct. Unit square is a type of square. Doesn't read correct.
Thank you, Zach. Yes. So we can just apply that simple principle is a type of, or is a kind of, to figure out which one of these makes sense. So if I apply it here, square is a type of unit square. That's not true, actually. And rectangle is a type of square. That's not true either. But I can say square is a type of rectangle. That's true. And unit square is a type of square. That's true as well. Now, there was some other reasoning about complexity. There was a complexity argument in there, like saying the one on the right is correct because of complexity or something like that. That's actually not true for general hierarchies. So usually the complexity is that children are more complicated than their parents because the children have new responsibilities that the parents don't have, or they re-implement responsibilities that the parents don't have. So this is why we're talking about this, because so many people get it confused. And I'm not like immune to confusion myself. I just know the guidelines to help me sort things out. But there's a common conception that somehow, because we're factoring as many behaviors as we can to the top, that the top is the most complicated object.
Then aren't you arguing that the left is better because the unit square doesn't have to care about side length, but then the square has to only care about the side length, one side length, and then the rectangle has to care about two things. So we're adding functionality, we have to add getters and setters. So like, isn't that, are you arguing for the other side then?
So I guess the point is, if you get confused, we are not modeling complexity. We're not trying to build a complexity hierarchy.
Yeah.
So these drawings in this context have nothing to do with complexity.
I see. I say
There's just nothing.
Usually,
Yes,
the lower
yes.
ones are the children are the more common.
That's right. That's right. That's right. We're not. There's nothing. There's no guideline that says the complicated ones go down the bottom and the simple ones go at the top. There's nothing like that. We're not talking about what's more complicated than another. Basically, yeah. Does that hopefully make sense? And this is confusing to so many people, not just here in this room, but in the entire world. And that's why this slide exists, to try to clear up this confusion. This is all about the is part of, is kind of. If you can follow that rule, you'll always be happy as a developer. If you just start to think, oh, parents are more complicated than children, or vice versa, then your class hierarchies are going to start to get very confusing. You won't even be able to understand them yourself after a while. Yeah. Any questions about that? What a great quiz question. Maybe something like that will appear on the test. Who knows? Okay, let's take a break then. We'll resume in 6 or 7 minutes.